In question 12, we've got a trig equation to solve, find the value of x for this equation. But first of all, we've got to show that 4 tan x, which is equal to 5 cos x, can be turned into this quadratic here in sine. Clearly, we've got to get rid of both tan and cos and transform them both into sine. Well, straight away, I can transform tan x into sine x divided by cos x. So we get this. Multiply through by cos x, so therefore I can say that 4 sine x is equal to 5 cos squared x. Got to get rid of the cos, and we can do that by using the first of the Pythagorean identities. Transforming cos, this will become 1 minus sine squared, so I can say that 4 sine x is equal to 5, 1 minus sine squared x. And we've got their answer, really. You can see it forming. Therefore, I can say that 5 sine squared x plus 4 sine x minus 5 is equal to 0. So let's have a look at part B now. Looking at the quadratic here, this is not going to be easily solved by inspection. You can either use the quadratic formula or pop it into the functions routine on a calculator. Either way, it's an equation in sine x, so the solutions will be in sine x as well, and it turns out that sine x will be these two solutions. Root 29 is about 5 and a bit, okay? So this is going to be neg 7 and a bit over 5, which is greater than 1, so therefore not a solution, because sine x must be between plus or minus 1. So we can reject this second answer. Working on the first answer, if you look this up on a calculator, you get that x is equal to 42.6 degrees, 1 dp. That's the first solution. Here is the cast diagram, and we've been asked for the solution between 0 and 360 degrees. Well, these two quadrants will be out because sine is negative. The only other quadrant sine is positive is the second quadrant here. There's the second solution, with this again as 42.6. And the angle we're actually interested in is that angle there, which if you take 42.6 degrees away from 180, we get the answer of 137.4 degrees. So our other solution is x is equal to 137.4 degrees. And those are the two solutions they were after. So now let's have a look at part C. Find the number of solutions of the equation for tan 3x is equal to 5 cos 3x in the interval massively increased to 1800 degrees. So for our original equation, we have two solutions between 0 and 360 degrees. Because we've transformed x into 3x, this new waveform will have a higher frequency, in fact 3 times higher. This will complete 3 cycles in the space our original wave completed just 1 cycle. So our two solutions will be knocked up by 3 to 6 solutions in 0 to 360 degrees. And that's because of the 3x from x. And now if you look at the range has gone up 5-fold from 360 degrees right up to 1800 degrees. So the number of solutions must be 6 times 5, which is equal to 30, and we're talking now of 0 degrees up to 1800 degrees. And that will be your answer.